The United States Navy is the most powerful in the world by tonnage and firepower, yet it struggles to build warships on time and on budget. Over the past 2 decades, the Navy's shipbuilding budget has nearly doubled while the fleet has barely grown, a paradox rooted in a dense web of military specifications known as MIL-SPEC. These specifications govern everything from the grade of steel in a hull to the cooling capacity of a radar system, originally designed to ensure warships could survive the worst conditions imaginable. In practice, they have become a straitjacket that slows construction, inflates costs, and prevents the Navy from adopting faster commercial manufacturing methods. This report examines how America's rigid specification culture became an obstacle to fleet expansion and what it means for competition with China. The modern MIL-SPEC system traces its roots to World War II and the early Cold War, when the U.S. military learned that warships had to survive torpedo hits, mine blasts, and near-miss nuclear detonations. Specifications like MIL-S901D for shock hardening and MIL-STD461 for electromagnetic compatibility were written in blood and steel, codifying hard-won lessons from combat. Over decades, these standards expanded to cover nearly every component of a ship, from the thickness of a pipe weld to the cybersecurity architecture of the combat management system. The logic was sound. If a warship is going to take a hit and keep fighting, every part must meet a level of ruggedness far beyond commercial standards. But what began as a rational response to existential threats has calcified into a bureaucratic ecosystem where specifications multiply faster than ships can be built, and changing even one standard requires years of review and approval cycles. One of the most damaging consequences of the MIL-SPEC culture is design instability, the practice of beginning construction before a ship's finalized design is in place. The now canceled Constellation-class frigate program stands as the definitive cautionary tale. Construction on the lead ship began in August 2022, but the functional design remained so unstable that over 18 months later the ship was barely 10% complete, and the Government Accountability Office explicitly found the Navy's approach to be inconsistent with leading ship design practices. In late November 2025, Secretary of the Navy John C. Fellon announced a strategic shift away from the Constellation-class frigate program, canceling all but the first 2 hulls already under construction. The program's collapse, from a planned 20 ships down to just 2, perfectly illustrates how design instability, driven by constant requirements changes and MIL-SPEC conformance costs, can kill a warship program before it ever puts meaningful hulls in the water. The financial toll of military specifications is staggering and quantifiable. A Rand Corporation study found that standards and requirements are a significant factor in ship cost growth, accounting for roughly 20% of cost escalation, a contribution factor comparable to complexity, labor, and equipment combined. Because MIL-SPEC mandates highly specialized parts instead of commercial off-the-shelf alternatives, shipyards cannot benefit from the economies of scale that make commercial shipbuilding faster and cheaper. Vendor bases have shrunk dramatically. According to defense officials, the submarine industrial base alone has contracted from approximately 17,000 suppliers during the Cold War to about 5,000 today. When a specialized MIL-SPEC valve or circuit breaker fails and the single qualified supplier has a 2-year backlog, the entire ship waits, adding millions in carrying costs for a vessel that cannot leave the yard. Even if MIL-SPEC requirements were relaxed overnight, America's shipyards would still face a crippling shortage of skilled workers. The American Welding Society estimates the United States will face a shortfall of 330,000 welders by 2028, with approximately 82,500 new positions needing to be filled each year. Navy shipyards in Maine, Mississippi, and Virginia struggle to hire and retain machinists, pipefitters, and electricians because they must compete with employers that offer comparable wages without the heat, confined spaces, and relentless overtime of shipbuilding. Navy officials and experts testifying before the House Armed Services Committee have cited labor shortages due to poor pay as the primary reason for production delays. The problem is not simply a matter of money, but of a generation that has not been trained in industrial trades after decades of deindustrialization and the shift to a service economy. The physical infrastructure of American shipbuilding is itself a bottleneck that no design reform can quickly fix. Since the 1960s, 14 U.S. shipyards that build vessels for the Navy have closed, and 3 more have exited defense work entirely, leaving the Navy dependent on a handful of aging facilities. Modern U.S. shipyards are often straddled with infrastructure dating from the World War II era, impacting both new construction and the introduction of advanced manufacturing technologies. The narrow supplier base compounds these physical constraints, with long lead items and specialty components becoming harder to source as qualified vendors dwindle. The Congressional Service Research has documented that cost growth in Navy shipbuilding is both significant and chronic, affecting every major program from destroyers to submarines, and that the average annual cost of the Navy's 2025 shipbuilding plan is estimated at over $40 billion over the next 3 decades. The consequence of America's MIL-SPEC-driven sclerosis becomes stark when compared to China's shipbuilding output. China's shipyards now control over half of the global commercial shipbuilding market by tonnage, while the United States accounts for roughly 0.1%, a capacity gap of more than 230 to 1. This massive commercial base allows China to pivot yard space and skilled labor to naval production, enabling the People's Liberation Army Navy to build advanced destroyers in under 3 years. The lead ship of the Type 055 class was built in just 29 months, while American methods require around 6 years per destroyer hull. The PLN now fields over 370 battle force platforms compared to America's 291, and roughly 70% of China's warships were launched after 2010, while only a quarter of active U.S. vessels are that modern. China's Type 055 destroyer, a 12,000-ton cruiser-grade warship, uses a traditional combined gas and gas propulsion system with 4 QC-280 turbines that produce 112 megawatts of mechanical power, enough for speeds above 30 knots. The Type 055 generates only about 30 megawatts of electrical power for its combat systems, and the real limitation is that it uses a mechanical drive system, not an integrated full electric propulsion architecture, meaning the ship cannot dynamically shift power from the engines to future high-energy weapons like railguns or directed energy lasers. Faced with the mathematical impossibility of matching China hull for hull, the U.S. Navy's May 2026 shipbuilding plan introduces a radical conceptual shift. The plan targets 450 platforms by fiscal year 2031, but this number includes 83 unmanned surface and underwater vessels alongside 299 manned warships and 68 auxiliary ships.
By embracing autonomous systems, the Navy hopes to bypass the traditional MIL-SPEC bottleneck entirely, since unmanned platforms can be built to lower survivability standards and produced in larger numbers at commercial-style speeds. The plan represents the first time the Navy has formally integrated unmanned vessels into its force structure at this scale, a tacit admission that the legacy acquisition system cannot deliver enough manned warships fast enough to deter a conflict in the Pacific. Whether this pivot succeeds depends on whether the Pentagon can resist the temptation to gradually apply MIL-SPEC standards to unmanned platforms, thereby recreating the same cost and delay cycle in a new domain.
The deepest irony of America's shipbuilding crisis is that the very standards designed to ensure naval dominance now threaten to undermine it. MIL-SPEC requirements produce warships of extraordinary survivability and combat power. A single Arleigh Burke destroyer carries more firepower than an entire Chinese coastal flotilla, and American nuclear-powered carriers and submarines remain unmatched in global reach. But survivability that takes years to build and costs billions per hull is strategically meaningless if the fleet is too small and too slow to grow in an era of massed, fast-produced adversaries. The challenge is not to abandon standards, but to recalibrate them, accepting that not every hull needs to survive a near-miss nuclear blast if the real requirement is to put enough hulls to sea to deter a fight in the first place. Reformers inside and outside the Pentagon increasingly argue for a tiered approach that applies full MIL-SPEC only to the most critical combat systems, while letting auxiliary ships and unmanned platforms be built to commercial standards. Until that cultural shift takes hold, America will continue designing the world's most survivable warships while steadily losing the race to build enough of them.